Hello everyone. Today I'll be presenting our project Smart Energy Management to you. Firstly, I wanted to express my deepest gratitude for the incredible opportunity that Elevate Solutions Private Limited has bestowed upon us. All these are team members who have worked on different teams, the team Elevate. The problem statement of the project is optimizing room conditions for reduced power consumptions by creating a system that collects real-time data. The sensor we use to collect the data are DHT1122. DHT11 is a commonly used temperature and humidity sensor. PSM out 0042 is a multifunctional sensor module that functions to measure power, voltage, current, and energy contained in an electric current. The microcontroller, which is ESP8266, is a low-cost Wi-Fi microchip with built-in TCP/IP networking software and microcontroller capability. So till now, we got an overview of all the sensors and modules used in this project to fetch the real-time data. Going further, we will be using Arduino IDE. So the first question arises is, what is IDE? It is an open source platform where we write code which can be uploaded on any module. And the code which we see here is called Sketch. In our project, we have used this sketch to fetch data from ESP8266. This real-time data will be sent to Flask server at regular intervals. As we can see on serial monitor screen, the data is sent successfully. Here we are connecting our microcontroller ESP8266 with the Flask server created by, and the connection is established using API endpoint generated by Flask server within a specified port number. After establishing the connection, the microcontroller is able to send data to the server, and then the further connectivity can be established with INFLUX DB. But before proceeding further to database, I would like to explain Node-RED and methods to create using Node-RED. Node-RED is an open source visual programming tool used for wiring together IoT devices, APIs, and online services. It provides a browser-based flow editor that allows users to create and deploy applications by connecting various nodes in a flowchart-like manner. Node-RED is commonly used in IoT projects, home automation, data visualization, and rapid prototyping. The key features of Node-RED are flow-based programming, visual editor, integration, built-in debugging, lightweight and scalable. The components used in Node-RED are HTTP input, debug, deploy, HTTP response. Next is, how can we generate JSON response? For this, we have to open Node-RED from its terminal, take a HTTP input node for the input, specify the address of the CSV file, HTTP response is sent out. Take one debug node for the output and then deploy. This is the output. AWS. I am going to explain how to send data or objects from Node-RED to an AWS S3 bucket with a timestamp. This can be useful for organizing and time-stamping data as it's stored in your S3 bucket. Firstly, install AWS Node-RED nodes and perform AWS configuration in your Node-RED. Set up your AWS credentials, including your access key ID and secret access key. You can do this by adding an AWS configure node and providing your credentials. Sending data to S3 out. Add an S3 out node in your Node-RED flow. Configure it with the necessary S3 bucket details like bucket name, reason, etc. Use a function node or other relevant nodes to prepare the data or object you want to send to S3 bucket. Connect the output of your data, and in the S3 out node configuration, set the key to include the timestamp so each object has a unique name in the bucket. Deploy your Node-RED flow to activate it. When you trigger the flow, it will generate a timestamp, prepare your data object, and then send it to the specified S3 bucket with a timestamp based key. You can verify the data is in your S3 bucket with the timestamp based key. Now, InfluxDB incorporating PostgreSQL into our project was a pivotal decision as it empowers us with a robust and a scalable database management system to efficiently store and retrieve our data. This data stored in PostgreSQL database can be used to create machine learning models for that data. This is the PostgreSQL interface where we have created a separate database for the data storage, and in that we have created table for the data collected from InfluxDB. Now the data being imported in the table format is visible here, and after this we connect this to Grafana interface for further visualizations and carrying out the insights of it. The next part is EDA. Now let's deep dive into exploratory data analysis. Let me clear it to you. EDA is a process in data science lifecycle that helps us to get a better understanding about data features and relationship between them. Firstly, we went through a process called data preprocessing in which we were handling missing values and outliers. We plot various graphs in process named as univariate and bivariate analysis to show the correlation between input features and target column. At last, we concluded that out of 28 data feature, we got 6 features that were linearly correlated with the output feature and help us in the further prediction of the model called feature engineering. I would like to explain a model that helps us to predict power consumption, something that affects all of us in our daily life. Don't worry if you are not a tech expert, I'll break it down in simple terms. Firstly, focus on the main problem is that we face that which machine learning model is best suitable to solve the problem. But guess what? After performing EDA, we found a straight line relationship that's clear indication of linear regression. We use a skitlearn library which provide linear regression. Now let's deep dive into steps. Imagine you have data about how much electricity a building uses over time. You might want to predict future electricity usage. This model does exactly that. Here how it works. Firstly, we have collected the data and performed data pre-processing to make sure that data is in a format our model can understand. Then we have checked for missing values and performed visualizations by creating graph to show how power usage changes over time. We have prepared the data and split the data into two parts. The first one to teach the model and the other to test how well it's learned. Next, we have built the model and make prediction. Our model starts making predictions about future power usage. It's like guessing what your next month electricity bill might be. Evaluating the model and visualizing predictions. Finally, we make a graph that shows the real power usage compared to what our model predicted. This helps us to see if our model is getting better at predicting over time or not. As we believe our model work, we can predict power consumption given time with the accuracy of 92% and R2 score is 0.92. In a nutshell, this model is like a smart assistant that learns from past data to predict future power consumption, making it easier for us to manage and use electricity more efficiently. So, the next time you wonder how much electricity you will need for the month, remember there is a simple yet powerful model working behind the scenes to help you out. Now we will be heading towards Grafana. Grafana is an open source platform that enables the user to visualize and analyze data in real time. We can perform this by installing Grafana And after this, we can establish a connection between database and Grafana by providing local IP address, port number, username and password for authentication. After this, we have to select data sources as Grafana support multiple data sources like INFLUX DB, PostgreSQL, etc. While we are using PostgreSQL, we can run its query through the UI. Here we have provided the name for data sources, the host address, username, password, and providing the InfluxDB bucket details. The dashboard we see here represents temperature and humidity graph, which shows the negative correlation between the temperature and humidity. The power factor graph is representing the variation of power factor with respect to timestamp. The average and voltage start is showing the average ampere and voltage throughout the day. Active power histogram is representing the value power which has highest frequency. That's all. Thank you. I hope you liked it.